So I'll just go over this, ठीक है, क्योंकि ज़्यादा चीज़ें लिखी हुई हैं. I'll just go over this quickly. और फिर हम वर्कशीट स्टार्ट कर देंगे, ठीक है. Halogenoalkanes में I'll just quickly go over that. कि what are halogenoalkanes? क्योंकि everything is written on the board. Uh, Polar compounds, ठीक है, which is why they're more reactive. Carbon जो होता है, that's positive when it's attached to a halogen, so it's more reactive. और वो भी बताया था कि dipoles can cancel out. They're not very soluble in water, although they are polar, so kind of more soluble compared to alkanes and alkenes, but still they can't really form hydrogen bonds, which is why not very soluble. ठीक है. और फिर formation पढ़ा था कि वो जो पहला रिएक्शन था, free radical substitution of alkanes, उसमें बन जाते थे electrophilic addition of alkenes, जिस तरह bromination वगैरह, उसके अंदर भी halogenoalkanes produce होते थे. And the third one is you could substitute an alcohol. उसमें OH can be substituted by chlorine, bromine, or in this case iodine. So different conditions for them: PCl3, PCl5, SOCl2 for converting alcohol to a chlorine, and so on. And so then we started talking about nucleophilic substitution, which was if you have a halogenoalkane, what you could do is कि NaOH aqueous reflux, तो OH आ जाएगा, or CN ethanolic, KCN ethanolic, or NH3 ethanolic, you would get NH2. This halogen, any halogen, could be substituted, and that was nucleophilic substitution. And we did talk about the mechanism के और वो भी पढ़ा था कि why did the mechanism happen? Why did one happen compared to the other one? So we did study that as well. और उसमें SN1 mechanism reason क्या थी कि I had told you that the first mechanism was for a primary halogenoalkane that you had a carbon which is positive because it's bonded to Cl, so it's a polar molecule. So the OH minus one or any of the three nucleophiles would get very strongly attracted to this positive carbon atom, and the positive charge on the carbon atom was very large. The reason it was very large was it's surrounded by hydrogen atoms. Hydrogen don't have electrons, so which is why the positive charge is kind of relatively strong. The OH minus one comes and gets attracted very, very strongly, and so both so in the middle somewhere carbon is bonded to five atoms. One of the bond is breaking away, the Cl is getting pushed away, the OH is coming in, bonding with it. And eventually you get an alcohol. The Cl eventually gets pushed away, as you can see over here. And it was a one-step reaction. And then you had an Sn1 mechanism. उसके अंदर क्या इशू था Sn1 mechanism? You had a tertiary halogenoalkane. और उसके अंदर I discussed कि tertiary halogenoalkane के अंदर the positive charge is not very strong. क्योंकि although this bond is polar, ठीक है, this CCl bond is polar, लेकिन it's surrounded by carbon chains. So there are lots of electrons around it. And if there are lots of electrons around it, this positive charge is not going to be very strong. Okay? It's going to attract the electrons from all sides, which would reduce the positive charge or the strength of the positive charge, which is why it's not going to attract the nucleophile in the first step. And which is why the Cl would first break away, and that would be a slow step. And once it breaks off, then the OH minus one or any of the nucleophiles are going to get attached. Okay, so unlike the previous one where the OH पहले ही आ जाता था अटैक करने, ठीक है, unlike the previous one where the OH would come right at the beginning, in this case it's not going to come right in the beginning. It's क्योंकि the carbon positive is not very strong, and so you would have to wait for the Cl to break off, and then you get a carbocation which is an intermediate, and it's a very stable carbocation. It's going to then attract the OH minus one and it's going to bond with it. ठीक है, ये सारा हमने किया था. And we talked about why Sn1, Sn2, so it was all about the positive charge. ठीक है, कि इस केस में प्राइमरी के अंदर the positive charge is so large कि पहले स्टेप के अंदर ही वो it's going to attract the nucleophile. It's not going to wait for it. दूसरे उसके अंदर टर्शी के केस में the positive charge is kind of very tiny, so it doesn't attract OH minus one initially. ठीक है, तो एलिमिनेशन रिएक्शन क्या था उसके अंदर मैंने बताया था कि NaOH एथेनॉलिक यूज होता है, तो ये सर आपने कल डिस्कस किया था आई थिंक. ठीक है, सो नाउ what we are going to discuss is uses वगैरह वो मैंने यहाँ पे पिछली क्लास में लिख दिया था. I'll just go over the uses very quickly. So the first thing is, okay, where do you use halogenoalkanes? The number one thing is they use in CFCs. ठीक है, you've studied CFCs in O levels as well. तो उसके अंदर you have chlorofluorocarbons. So it's a carbon which is bonded to fluorine and chlorines. ठीक है, it could be any number of carbon atoms, any number of fluorines, any number of chlorines. That's a CFC. Now CFCs are kind of unreactive and they're volatile liquids. Uh, Why are they unreactive and volatile? Because the dipoles in a CFC they usually cancel out or almost cancel out, which is why they don't have a lot of intermolecular forces. They don't attract other molecules that strongly. So they're going to be unreactive. There won't be a lot of positive or negative charges concentrated at a particular point, non-polar molecules. So they won't attract other molecules very strongly. And if they don't attract other molecules that strongly, so they are unreactive and plus their boiling points and melting points would also be low. So why do you need liquids? The reason you need liquids is the number one liquid that you use is water, and water is a very bad liquid. Because water is a highly polar substance. Uh, मतलब water is a highly polar and a highly reactive substance. कि अगर मेटल के ऊपर पानी गिरता रहे तो क्या होता है कि वो रस्ट कर जाता है. ठीक है, so water is very reactive. Uh, and you don't want in a lot of places you don't want a very reactive for example AC के अंदर ना you want coolants in your AC air conditioner. Now if you use water as a coolant you can possibly use water as a coolant, but the thing would be that the AC air conditioner would rust very quickly because of the water in it. So you're always looking for liquids that uh, uh, specifically in heat transfer, and in a lot of places you need liquids like the radiators in the cars. Okay, all sorts of places. If it's a centrally heated house, then there are radiators in the house, and there's a liquid flowing through them. Now you don't want that liquid to be water because water is going to destroy everything. Okay? It's going to react with everything. So that's where CFCs come in. The coolants, the refrigerants, the deodorants, freons. Uh, I mean, most of these words they pretty much mean the same thing. Coolants, refrigerants, freons, they're pretty much the same thing. Deodorant you already know, uh, and I said, why do you use them as a deodorant? Because they're volatile. You want the perfumes to actually evaporate and spread out. So if you use water, water doesn't evaporate that quickly. Okay, perfumes they evaporate very quickly. I said, but anyways, and anesthetics maybe it's they're used in anesthetics. You are part clear? Ibrahim, is this clear? Minail, clear? Is this clear?
Yes, sir.
Yes.
Yeah.
Okay, so what's wrong with CFCs? CFCs you've studied, they destroy the ozone. What is ozone? It is present in the upper atmosphere and it reflects UV light because it causes skin cancer, and UV light is very harmful. It's probably going to kill all of life. Because UV light is going to it breaks. It's a very high density frequency, and it breaks a lot of bonds. So because of the excessive UV rays, even all the bonds in plants and animals and any bond, okay, that's going to break. So in humans, it causes skin cancer. Uh, Now, ozone is this haze-like substance. It's like fog-like substance. Like if you see ozone, it's going to resemble fog. Okay, it's this haze, this fog that's present in the upper atmosphere. It blocks most of the harmful rays. Uh, it's also present in the lower atmosphere. In the lower atmosphere, it's kind of not. Uh, uh, it's a very harmful substance in the lower atmosphere. You don't want it to be in the lower atmosphere because it's present in the form of smog, okay, which is usually present in cities. If you look at a city, it's you have this hazy, polluted atmosphere, and the number one reason for that haziness and this uh, uh, smog-like atmosphere, that's because of ozone. In some cities, this haze is like a huge issue, okay, especially in South Asian cities. most South Asian cities are very polluted. Okay? Including Pakistan and India, you have a lot of haze and smog, and the reason for that is the number one reason is cars. Cars, they produce NO2, and NO2 is an oxidizing agent. What it does is that cities के अंदर you have a lot of cars, and the air burns up because of the high temperatures in the cars. ठीक है, car exhausts and car engines are really hot, so the air nitrogen, which usually doesn't react, it's inert. What it does is it reacts with the oxygen and forms NO2, which is a good oxidizing agent, and NO2 starts oxidizing oxygen and starts converting it into O3. When it gets converted into O3, ozone, in the lower atmosphere, that's smog. That's the hazy atmosphere in the cities, and it causes breathing problems as well. It causes asthma because it's going to combine with your hemoglobin, and it would make your blood less efficient in transporting oxygen. ठीक है? Pasa, is this clear? Abba, is this clear?
Yes, sir.
Yes.
Achha, so you want ozone in the upper atmosphere, not in the lower atmosphere. So now the other thing is you have here's your CFC, and in the upper atmosphere you have very strong UV light. Okay, that's present in the upper atmosphere. This is what's happening. Achha, so this is what's happening in the upper atmosphere. Um, so radicals are produced. The bond breaks, CCl bond breaks, specifically CCl bond breaks. Uh, and the reason for that is that the CCl bond is the weakest. The CF bond, smaller atoms will make stronger bonds. So the CF bond is a lot stronger. So the CCl bond breaks and produces Cl radicals. These Cl radicals, as we have already studied, uh, so these Cl radicals, they want their electrons back. So they're going to attack oxygen. Oxygen would go and bond with Cl, and OCl radical would be produced. Why is it a radical? Because now oxygen doesn't have complete bonds. But oxygen needs two electrons. Cl is only giving it one electron. So oxygen's bonding is not complete. Cl's bonding is complete. It got its electron from oxygen. So OCl radical is produced and ozone breaks into O2. The OCl radical, the oxygen wants another electron. Oxygen needs two electrons. It's in group 6. It got one from Cl. Now it's trying to search for another electron. It's going to attack the ozone again. And eventually it's going to form two O2 molecules, and the Cl radical would be reformed. And the whole process keeps on repeating. Remember this part, okay? This is important. You have to write this in your answers when they discuss about destruction of ozone. Okay, so Cl radical, how do they play a part? That's how they play a part. Okay, they start attacking ozone so that they can complete their own bonds. And the thing is that one Cl radical could break down a lot of ozone molecules. Uh, so you don't need a lot of Cl radicals. You just a very small amount of Cl radicals can destroy a very large amount of ozone. So the overall reaction is O3 gets converted into O2. Okay, is this clear? Abba, is this clear? Ibrahim, Bazga?
Yes, sir.
Yes.
Achha, so the solution is stop using CFCs. Don't use CFCs. So what are the replacements? The replacements are that you can use hydrocarbons. You can use you want a liquid. You're looking for a liquid. That's probably a replacement for water. Okay, you don't want water. Water is very reactive. So might use a hydrocarbon. Hydrocarbons are pretty good. They're non-polar and they're very unreactive. Like alkanes, that's the first thing that we studied about alkanes, that they were unreactive because they're non-polar and they're also volatile, but they have low melting and boiling points. The CH bond is non-polar. But the problem with hydrocarbons is that they are very, very explosive. I mean, they burn, they all combust. So, so they're not good replacements. Like if you have an air conditioner and that air conditioner has butane in it, then the chances that air conditioner can explode. So not a very good replacement. Uh, so what else could you do? You could use CFCs. You could use halogenoalkanes that don't have Cl because remember it's the CCl bond that is weak. The other bonds are kind of strong. The CF bond and the CH bond, they're kind of strong. So you might there's another thing that's instead of Cl you could have H in it, but that would make the bond kind of polar. Uh, so you're looking for replacements. Just don't use Cl. The CCl bond is weak. Okay, so you can replace them with hydrocarbons or with halogenoalkanes that don't have Cl in them. अच्छा उसके बाद ये कि polymers, there are a lot of polymers that contain halogenoalkanes, a lot of polymers that you study that you've already studied in as you've already studied in O levels, like PVC, polyvinyl chloride. So in polyvinyl chloride you have an alkene and an ethene molecule. Basically, it's a chloroethene molecule where one of the hydrogen is substituted by a Cl, and the alkenes they add up, and in addition, polymerization happens, and lots of monomers join up. So where is PVC used? PVC is probably one of the most popular building materials. It's getting more and more popular with every passing day because previously in older times only pipes were made from PVC. Then they started making tiles. Like a lot of your wooden flooring, it's actually fake because they're made out of PVC. So it's they're just plastic tiles. Uh, Now they've started making windows. Like people switched from steel. Like 40 years ago, they were making windows out of steel and doors out of steel. Then they switched to aluminium because aluminium got cheaper, electricity got cheaper, and you made cheaper aluminium. Aluminium was better because it did not rust. But now even aluminium is getting replaced with PVC. Now a lot of windows that you see now in modern buildings, they're made out of PVC. And a lot of buildings, especially your high-rise buildings, they have this PVC cladding on top of them. The shiny cladding that's usually made out of PVC. So PVC is kind of a very popular building material, and it's kind of very strong. Reason it's strong is that the CCl bond is polar, so PVC strands are going to attract each other very strongly. So the strands in a PVC chain would attract other strands very strongly. Now this PVC molecule is not very different from a polyethylene molecule, but polythene is a very soft. It's your plastic bag, polythene bags. उसके अंदर क्या होता है? The Cl has, I mean, there is no Cl except the only difference between a polyethylene and a PVC is that instead of the Cl, you have hydrogen over here. Hydrogen makes the strand non-polar. क्योंकि अगर if all of them are hydrogens, then the molecule would be non-polar. So in polyethylene, the strands don't attract each other. So if you look at a plastic bag, you can easily stretch it or tear it apart. But just because of adding one Cl, you introduce polarity to the strand, and when you introduce polarity, the chains they start attracting each other very strongly, and which is why you get tougher substances. ठीक है? Is this clear? Clear, Minhail? Is this clear?
Yes.
अच्छा, उसके बाद the last one is PTFE, which is polytetrafluoroethene. Same structure except के it's an alkene.
So
Except
don't we call this polytetrafluoroethylene instead of ethene?
ethylene. मैं check कर लेता
जी.
हूँ. As far as I know, ethylene is something. Check. Let's confirm कर लेते हैं. PTFE. So it is actually ethylene. But I do remember it's also used as I'm just saying कि नहीं, everywhere it is नहीं, ये गलत है. It is actually ethylene. This has to be corrected. Like I'll just check if I'll just check कि चलो ये तो नाम हो गया, लेकिन systematic naming में it would be ethene. But I'm sure कि polytetrafluoroethene is not wrong. क्योंकि IUPAC nomenclature में this is This is tetrafluoroethene. ठीक है? uh, क्योंकि it is ethene. It is ethene, two carbon atoms. तो नेमिंग के it would be probably
जी
क्योंकि ये उसका वो नेमिंग है ना, वो इंडस्ट्रियल नेम है ना. So that's
हम्म
so so I'll just check. It's definitely nothing wrong with ethene. ठीक है? देखो, this one also, this is polyvinyl chloride. ठीक है? That's the industrial name.
हम्म,
But इसका जो टेक्निकल
जी
नाम होगा वो क्या होगा? It's chloroethene. So it's polychloroethene. ठीक है? Vinyl,
जी
that's the industrial name. देखो मैं चेक कर लेता हूँ. IUPAC nomenclature में it should be wrong. Polytetrafluoroethene. This is polytetrafluoroethene.
in case if it was ethylene what would the structure be like then
क्या ethylene? वो तो industrial name है ना. वो तो
जी
आप you call it anything. But it's called Teflon. तो
नहीं ethylene is मतलब the nomenclature name Teflon is like industrial name right
हाँ.
तो मतलब अगर हम इसे
Let's
ethylene कह रहे तो लगा जी
ये है ना. वो कह रहा है कि इसको क्या कहते हैं? इथीन कहते हैं ना. ठीक है?
जी जी
तो ही इज सेइंग कि C2H4 जो है ना, उसको इट्स आल्सो रेफर्ड टू एज इथाइलिन्स.
हम्म
ठीक है? जिसमें वो
जी
डबल बॉन्ड. तो लेकिन वो यहाँ पे ना कंफ्यूजन हो गई. इथाइलिन्स जो होते हैं ना, दे आर काइंड ऑफ, मतलब वो इट्स यूज, some people use it, some people don't use it. तो वो मतलब इट्स नॉट रियली आयोपैक. ठीक है?
गेट ठीक है
अच्छा, इस पे वापस आते हैं कि अच्छा इसका क्या इशू था कि इट्स अ नॉन स्टिक इन कुकिंग यूटेंसिल्स. तो what's a non-stick in cooking utensils? के you have that black substance on your frying pan, और उसके ऊपर ना there's a uh, uh, it doesn't, things don't stick to it. Why don't they stick to it? Because this molecule, this polymer is non-polar. It has fluorine in it. Fluorine is highly electronegative, but the dipoles, they get cancelled out. One of the fluorine is pulling it upwards, the other one is pulling it downwards. So the dipoles kind of get cancelled out, which is why it's going to be non-polar. So non-polar things don't attract other things, which is why it's a non-stick. So if you're frying an egg, it's not going to stick to the frying pan. The other thing about this is that the CF bond is very strong. So that means it's heat resistant as well. But you wouldn't be using chlorines over here. Bigger atoms, they make weaker bonds. So वो decompose कर जाएंगे if you have high temperatures. So fluorine kind of, it's a small atom. It makes very, very strong bonds. So that's another reason why this can be used as a non-stick in cooking utensils. ठीक है? ये सारा clear है? Abhay, is this
जी
clear?
सर
ठीक है. अच्छा, so what we're going to do is we're going to start with इसके past papers. ठीक है? Just starting quickly. Halogenoalkanes and the past paper questions.
so we are only left with carbonyl compounds right in organic
हाँ, क्योंकि carboxylic acid भी most of them is you're left with carbonyl. That's one. Carboxylic
जी
acid is mostly in A2, और उसके बाद फिर कुछ खास नहीं है.
so we will be practicing past papers कि नहीं बस we will be ending the session then
नहीं, past papers और other topics भी है ना.
अच्छा
वो डिस्कस कर लेंगे ना कि we started with organic, we jumped to organic. ठीक है? क्योंकि that was important.
अच्छा
क्योंकि ऑर्गेनिक का बाकी किसी चीज के साथ कोई खास लिंक नहीं है. अच्छा, anyways, this one, but mostly past papers now. ठीक है? अच्छा, let's start with this question. पहला तो हो गया this one. So this one. Let's start with question number 2. Halogenoalkanes react with aqueous alkali. One mechanism of this reaction has the following reaction pathway diagram shown. So remember, it's halogenoalkane reacting with an alkali. ठीक है? So let's go back. Notes देख लेते हैं कि what happens when halogenoalkanes react with alkali. कहाँ पे है? Where is a halogenoalkane reacting this one, nucleophilic substitution. So halogenoalkane, like any halogenoalkane reacting with an alkali. So the reaction pathway diagram that he showed was Sn2 mechanism. Okay, Sn2 mechanism I told you had a one step. Okay, an alkali had OH ions, and the OH ions would attack the carbon positive primary halogenoalkane and would knock out the Cl. So that was a one-step reaction. So he's basically talking about this reaction. So let's go back and so which of the following statements are correct? Yeah, yeah, clear. Abha, is this clear? Ida, Abha, is this clear? You had to identify what was happening. ठीक है, which particular reaction was this?
Yes.
So this was primary halogenoalkane, and this was Sn2 mechanism. So the reaction is an example of nucleophilic substitution. That's true. Then he's saying between X and Y, the halogen bond will be lengthening. So let's go back. What's happening? So there's a carbon with a halogen. So what's happening? The C halogen bond is lengthening. The Cl is getting pushed away, and the OH is coming in and bonding with the carbon atom. So that is true as well. Okay, the C halogen bond is lengthening. ठीक है, ये clear? Mirahil, Bazga, is this clear?
Yes, sir.
अच्छा, बाकी ये कि the energy difference between X and Z represents activation energy. What is activation energy? Start reactant to the top. So X and Z, that is the activation energy. So that is also true. As the next one. And so this one is, इसमें you would be required to know something else as well. Can we do this? थोड़ा सा कर लेते हैं. He's saying but we can't because it all depends on this. We haven't done this yet. CFCs undergo homolytic fission by ultraviolet irradiation in the atmosphere, which radical could result from this irradiation. This is a CFC. Tell me which bond is most likely to break?
The chlorine and carbon atom. Chlorine and
So
carbon.
I just told you that the CF and the CH bond, they're kind of strong, so they're not going to break easily. It's the CL bond that is the one that is weak. You can also check the bond energies. So this is the one that's going to break. So if that's the one that's going to break, though, what radical would be produced? Out of A, B, and C, D.
B, yes, B.
No, it won't be B because this molecule has two chlorines, right? So remember, I told you
Acha. C. It would be C then.
Okay, so the Cl is the one that's most likely to break away. Clear? Mirahil, clear? Abha, is this clear?
Yes. Yes.
So next one is chloroethane can be formed by bromoethane in two steps. Which statement of these steps are correct? X is nucleophilic substitution. It is. We just bromine gets substituted by OH. Aqueous NOH is the reagent in step X. That is also true.
Correct.
Okay, and this is not correct. Okay, remember we did OH to Cl. How do you get from OH to Cl? If you want to, this was the first thing. How do you make halogenoalkanes? The way you're going to make halogenoalkanes is बिल्कुल start के अंदर. This one. That the OH to Cl, you use PCl3, PCl5 or SOCl2, not NaCl. That's not used. So this one is incorrect. So next is so this one. He's saying, so this one is a nice question. He's saying there's 1,2-dibromo-3 chloropropane and has been used in the control of earthworms. What would be the best synthesis of this compound, DBCP? So best synthesis.
Sir, I
First-
can't see the question. ठीक
Huh?
नहीं हो गया वो, it wasn't loading ना, the question is
Acha. So first thing is DBCP. What is DBCP? कितने कार्बन होंगे इसमें? So there's propane. So that's a total of 3 carbons, right? Acha, what else? There's 3 chloro and 1 2 dibromo. So 1 2 dibromo. So there's a Br here and a Br here. And 3 chloro. Yeah, na? So this is your DBCP molecule. Rida Heba, is this clear? Ibrar clear है?
जी
ठीक है, ये सारी branches थी. Before this there were branches. 3 chloro, 1 2 dibromo, and it was propane, so it was 3 carbon atoms. So what would be the best synthesis of this? The first one is, I said, now listen very carefully. What is the first reaction? I mean, we have to make this thing right here. So the first, I'm going to talk about A. I'm going to discuss A. A is you have 3 carbon atoms and there are a bunch of hydrogens here, and there are 2 hydrogens over here, and there are 2 hydrogens over here and a Cl over here, and he's saying कि इसको react करो with 2 bromines, right? So where do you want the bromines to be substituted? You want to get rid of 1H over here and 1H over here. मतलब 1 2 पे at 1 and 2 you want bromines, right? Can anyone tell me what reaction is this? Like this one.
substitution.
It is substitution. It's free radical substitution. Okay. Remember, free radical substitution was that under UV light, the bromine would break into radicals, and the bromine radicals would come in, and they would take away the hydrogens, right? This was all that we studied in free radical substitutions. So it's a normal saturated compound, and they always have free radical substitution. So wo jagah khali hogi, another bromine radical would come in and take its position, right? Is that clear? Do you remember this, Ibrar Basga?
Yes sir.
Abba, is this clear?
Yes.
Okay, so remember, so this is free radical substitution. Now, is this, so you can possibly, I mean, this thing is possible, like you use UV light, the bromine radicals are formed and they get rid of the HBr molecules are going to be produced, and the remaining bromine radicals would come and combine with the carbons over here. Why is this not a good way of producing DBCP?
Because we can get a mixture of products.
हाँ, क्योंकि मतलब who's going to determine which hydrogen is going to get substituted? It could be any random hydrogen. I mean, this H could get substituted, this H could get substituted. The bromine radicals don't really care. Okay? Any one of the hydrogens might get substituted. So you're not always going to get a bromine at position number 1 and position number 2. That's the specific molecule that you have to make. So the yield of the products is going to be very low because you're going to get a number of products, a number of many different products. ठीक है मिनाहिल, is this clear? Baza clear है?
Yes. Yes.
Yes.
अच्छा, and the same is true for this one. Okay, now this is also free radical substitution. Like if I draw this, it's a CH3 carbon. So this one is HBr. There's a Br on the second one as well, and there are 3 H's. Now to convert this molecule into DBCP, the bromines 1 and 2 pair bromines are already there. You want a Cl at the third one, and he's saying add Cl2. Now you can't. It's going to be वही issue होगा. It's free radical substitution. The Cl radicals would be produced, the H would be taken away. But why would this H be taken away? It could be any of the H's that could be taken away. So the thing is, it's not always going to produce DBCP. I mean, there's a very small chance that it can be DBCP. So the yield is going to be pretty low. Okay, Brad, is this clear? So which one is going to be the right one? It's going to be
C.
TKC is the one because it's an addition reaction. It's bromination. You have a double bond now. So this one already has a Cl. So अगर dark के अंदर करोगे ना, if you add a bromine molecule in the dark, the double bond is going to turn into a single bond, and bromine's electrophilic addition would happen, and bromines will get added at exactly the positions that you want. I mean, they're not going to get added anywhere else. They're going to react with the double bond. So hence, C is going to be the correct. C is going to be the correct answer. ठीक है?
Sir, why not D?
क्योंकि PBr5, I mean this thing wasn't actually used for converting. किधर हमने किया था ये? इधर मैं दिखा दूं. नहीं, just a second. ये कौन सा? अच्छा, इधर मैं दिखा देता हूँ. This one, ये जो PBr5 है ना, it's actually this one. You don't actually use PBr5 because PBr5 is very unstable. What you do is you react red phosphorus and bromine and you heat. वो end में ना बीच में PBr5 या PBr3 बन जाता है. ठीक है? These are highly unstable compounds, which is why आप उनका ना raw material use करते हो. You add red phosphorus and bromine. Anyways, it's used for substituting an OH with bromine. So OH, there is no OH over there in this question. Like इसके in the last one, there is no OH. Clear है, Ibrar?
G, sir.
As a next one, easy question. Which one would cause the depletion in ozone, or the greatest depletion in ozone? I mean, greatest depletion of ozone layer.
A.
ठीक है, so it's going to be A because it's the CCl bond that's weak, and that breaks in the upper atmosphere. So this one is what is this? 1,1-dichloropropane reacts with aqueous NaOH in a series of steps to give propanol. What is the mechanism of the first step? So remember, it's a halogenoalkane. It's a halogenoalkane, so the Cl is probably going to get substituted by OH. ये भी हमने किया है. What's the mechanism?
Elimination.
नहीं, halogenoalkanes का एक ही mechanism है ना. You only have one mechanism, which is
Electrophilic.
it's Sn1 or Sn2. It's nucleophilic substitution. Like the OH would knock out the Cl and take its position. ठीक है? So he's saying there's a series of steps involved, but the first step he's talking about the first step. So if you add NaOH, the Cls are going to get knocked out by the OH ions, and that's nucleophilic substitution. Just remember, halogenoalkanes, it's always nucleophilic substitution. ठीक है? Rida, is this clear? Rida, कौन सा question किया था? How is it non-polar? One second. The next one is this one. This one is the tertiary halogenoalkane mechanism. The nucleophile is not going to be attracted initially. ये मैंने explain किया था क्योंकि the carbon is not very positive. Why is it not positive? Because it's surrounded by carbon chains, lots of electrons. The electrons are going to all kind of neutralize the positive carbon atom. ठीक है? So the carbon is not really interested in the nucleophile initially. So it's going to break off first, form a carbocation, and then the OH minus one would come in. And it's a two-step reaction. Remember, this was a two-step reaction. This was Sn1 mechanism. Why do you call it an Sn1 mechanism? Wait, मैं उसका answer कर लूं. लेकिन Rida, did you get the answer? Okay, I'll just quickly explain again. Okay, how is this? I'll just quickly explain. Okay, if there's a fluorine pulling the bond on one side and another fluorine on the other side, plus everywhere there are fluorines. For example, a carbon atom and it has fluorine everywhere. Okay, the dipoles would cancel out because all of them are trying to pull electrons in different directions, which is why no one would be able to pull the electrons in their direction. Okay, all their directions, all their vector diagrams, all their forces of attraction, they would get cancelled out. Okay, Rida, is this clear? अच्छा इस पे आ जाते हैं. This was a two-step reaction. This was the second one that we did. कहाँ पे हमारा? So I had specifically told you that it was a two-step reaction. ठीक है? First a carbocation is formed and then this one. And I had also told you that the second peak has to be smaller because the second step is the fast step. It has a lower activation energy. So there are two reactions given, C and D. Both of them are two-step mechanisms. Like you start at the reactants, you reach the intermediate, and then you get your products. Reactants, intermediate, and products. But it's going to be D. The second peak is he's already mentioned that the second is the fast step. So it has a lower activation energy. It's not going to rise that much. Uh, so remember that. So ye question, this nothing to do with this. Let's talk about this question. Now this one. So one thing that we did not do, one thing that I think we did not do. It's a small point, okay, a very small point. वो हम यहाँ पे लिख देते हैं. All this nucleophilic substitution, okay, about these nucleophilic substitution. Remember this, कि the bond strength, our F bond is very strong, or let's talk about carbon and F. Okay, so it's a small point, which is that the carbon and F bond is very strong. And the carbon and Cl bond is kind of weak. The carbon and iodine bond is very weak. Bromine की तरह एक second. Bromine bond, and then you have carbon and iodine bond, right? So the first one is kind of unreactive because the bond is very strong. So remember, in nucleophilic substitution, you have to break the old bond, and then you form the new bond. So if the bond is very strong, ये भी हमने उसमें PTFE में भी किया था. CF bond is very strong. So nucleophilic substitution is going to be very hard for CF, although it's polar, but it's kind of a strong bond. The CI bond would break very easily, so it's going to be more reactive. Okay, this one is going to be a lot more. It's going to be a lot more reactive. So remember this point about nucleophilic substitution. Okay, it's not that all halogenoalkanes would have almost the same speed of reaction. जिनके weak bonds होंगे ना, they would the weak bonds, the one with weak bonds would react very fast, and the one with strong bonds will not react very fast. ठीक है? Vinay, clear? Pasga, is this clear?
Yes.
Acha, in this question, now this is substitution happening. ठीक है? We've already done that. There's a halogen that's getting substituted by OH. ठीक है? That's what's happening. And he's saying a student investigated the amount of NaX produced by hydrolyzing this thing. Hydrolyzing means the hydrolysis is always a reaction with water or with OH ions, right? So that's nucleophilic substitution happening. And another halogenoalkane in a given amount of time, and sodium halide formed was greater with Y than with this thing. So what he's saying is that this thing, let's say it's NaCl or NaBr or NaI, okay, whatever it is, more sodium halide is being formed in Y compared to this in a given amount of time. Why is that? Maybe the reaction with Y is faster. Like over here, the OH is coming in and the Cl is getting substituted. The Cl gets knocked out, right? But it's happening at a slow rate. But its height is lesser. The number of moles of NaCl is lesser, so there are fewer Cl minus 1 ions. So there are two ways. Either Y has a faster reaction. So so this one could either be Br or I. Because Br and I have weaker bonds, so it's a lot easier to substitute. And so the OH would easily knock out the Br. OH would easily knock out the I in the halogenoalkane. The CCl bond is relatively strong, so the reaction would be slower. Is this point clear? Rida, Hiba, Abba, is this clear?
Yes.
So it's either going to be Br or I. What about the first one? Could it be this one as well? Number one, anyone? Like we know that 2 and 3 would be correct, but what about 1? Like in 1, if the OH ion comes along and tries to substitute the Cl, there are 2 Cls. So possibly 2 Cls could be substituted. So the amount of Cl ions that would be produced would also be high. I mean, it's going to be a large amount of Cl ions that would be produced if you have a halogenoalkane that has more Cl ions. Do you get my point? I mean, this one had just 1 Cl ion. So if OH ions come along and they knock out a Cl minus, only 1 Cl minus 1 is produced. But over here, there could be double the amount of substitution happening because there are 2 carbon atoms that are positive. So one OH ion could be working on one of the carbon atoms, the other one could be knocking out the other Cl. Is this point clear? Mirahil clear? Basra, is this clear? Ibrahim? Huh?
Yes.
So all,
Yes.
so all 3 are correct. Okay. अच्छा सॉरी मुझे टाइम का तो पता था कि ये द क्लास ये 10 मिनट्स ऊपर हो गए चलो ठीक है लेट्स कंटिन्यू द नेक्स्ट टाइम ठीक है
चलो अल्लाह हाफिज़ है, thank you.
ओके ओके ठीक है अल्लाह हाफिज़